Okay, good morning. Doing this video to go over our 6B notes here on the focus and directrix of root functions. Okay, so I want to talk just briefly about focus and directrix when we had a quadratic function. So when we had a quadratic function, and let's say it looks something like this. Let's do it in green. So we had a quadratic function. We had a parabola that kind of looked like that. I don't know what happened to my mouse right here. Let's redraw it. So we had parabola like this. Okay. And there was an axis of symmetry that goes down every parabola. Okay. And on that axis of symmetry, we had a point that was called the focus. All right. And that point, uh, that's the focus that's there, had a distance of P that was from the vertex. Okay. So from the focus to the vertex had a distance of P. Okay. Now the vertex to the directrix also had a distance of P. Okay. And so we had a directrix down there. So coming down to fill some of these notes out, we had a point that lied on the axis of symmetry that had a distance of P from the vertex. That was a focus. Okay. And the directrix was a line that was P units from the vertex in the opposite direction of the focus. Okay. Now, any point that was on this graph right here, any point that's on this graph has the same distance to the focus as it does to the directrix. Okay. So this distance, I know it's not really drawn to scale, is the same as this distance right there. If you need to go back to look at the 5B notes, the 5B notes kind of covers all this stuff as well. Okay. So any point on the graph would be equidistant to the focus and the directrix. Okay. Now, on our 5B notes, okay, the distance of P was equal to 1 over 4A. Okay, so if we had a quadratic where we had, f of x equals, 5x squared plus 6x minus 1 or something like that, we knew that the A was equal to 5, and so P would be 1 over 4 times 5, which is really 1 over 20. Okay, that's for an example in a quadratic. Okay, in a quadratic. Now, when we have a square root function, it's not that it's the formula is a little bit different, and so I want to make sure that we can get the formula here for when we have a square root function. Okay, so I'm gonna go ahead and clear my screen, pause the video if you need to, and catch up. This here is P units, in case you're not sure, P units of distance in the opposite direction. So I'm going to clear the screen here real quick. Okay, if we're looking at the vertex form of a square root function, we have y or f of x is equal to a parentheses square root of x minus h plus k. Okay, so that's the vertex form of a square root function. Okay, now in the root function, okay, the p is going to have a different formula. So the p is going to be equal to a squared divided by 4. Okay, a squared divided by 4. I'm going to go over here to GeoGebra and do this one example here real quick. And so we'll sort of toggle back and forth here. So we have f of x equals negative 6 square root x minus 1 plus 4. And of course, we got to do the positive of that as well. So we'll also have a positive 6 x minus 1 plus 4 as well. So I'm going to come over here to GeoGebra and graph these out. So here, I'm going to come to our thing, get this out of the way. So -6, y equals -6. And we have the square root, parentheses x minus 1 plus 4. And then we're going to have y equals +6 square root x minus 1 plus 4. So we have our two graphs here. Okay. We have our two graphs. So our vertex is at 1, 4. Okay. You see our vertex there is at 1, 4. So I'm going to put that point there, 1, 4, for that vertex as well. Okay. Now we know the axis of symmetry of this thing is going to be this horizontal line y equals 4. So we can put that there if we want to. Okay. To do our axis of symmetry. Okay. So we want to find our p. Okay. We want to find our p. Well, in a root function, as we said a minute ago, p is going to be a squared divided by 4. Okay. P is going to be a squared divided by 4. All right. Well, a squared, so we see a is -6. Okay. -6 squared is 6. And we divide that by 4. Or a squared, excuse me, is 36. So 6 squared divided by 4. So our p is going to be equal to 9. Okay. So the p is equal to 9 here. Now remember, the p is the distance from the vertex to the focus and the vertex to the directrix. So here we have our vertex of 1, 4 here, right there. So we're going to have to go over by 9 units to get our focus. So we're going to add 9 to our x value here to get our focus point. Okay, so our focus point here, if we add 9 to 1, is going to be 10, 4. That's going to be our focus right there, 10, 4. And I'm going to clear my screen real quick. And so now we have a focus point at 10, 4. All right. Now the directrix is going to be a vertical line that's 9 units in the opposite direction. So from our vertex to our focus, that had a length of 9. So our vertex to our directrix also has to have a length of 9. Okay. But now we're going to subtract the x value. So our x value here was -1 or +1, excuse me. So we go back by 9. We're going to have the point -1 or -8, excuse me, 4. Okay. And now we'll draw our directrix through that point C. Okay. So we'll do a perpendicular line, point C and through there. So this vertical line right here is our directrix. Okay, so our focus point is at 10, 4. Our directrix line is x equals -8. Okay. Now to go prove it like we kind of did back in the 5B notes, what we'll do is we'll plot a point on this graph. Okay. So I'm going to go to my geometry tools here. I'm going to put a point. I'm just going to put a point right there, point D. It's on a graph. Now remember, the rule is the distance from D, from this point D to the focus is going to be the same distance as point D perpendicularly to our directrix. Okay. So we can calculate the distance here, distance or length. We're going to hit this thing right here, DB. And we see that DB has a length of 11.4. All right, now we got to find the distance from D to our directrix. And we see that that distance is also 11.4. Okay. So now as I erase these here, I'll zoom out of this thing a little bit so we get a nicer little picture here. So D to B is 11.4. D to this line here is 11.4. Now, if we were to move D anywhere along this thing, we see that the distance from D to B, point to focus, is the same as the distance from D to this line I right here, which is our directrix. For some reason it won't let me drag it down here, but if we want to make another point, we can make a point here, E, and sort of repeat the process. Find the distance E to B is 16.1. E to our line is 16.1 there. So any point is going to be equidistant to B and our directrix I. It's a way that we can just sort of go on this graph here and prove our point here. Okay, if you have any questions on how to use this or something like that, I'll be happy to come around and sort of show you. You can rewind the video if you need to, pause it and sort of work it as you go along if you need. So that's that. So in that case, we found our focus point 10.4, our directrix at x equals -8, all by just applying the formula of P is equal to a squared divided by 4. Okay, so that's sort of the essence of these notes right here. So P is a squared divided by 4, so we did all this, and so we found our focus was 10.4. Directrix was at x equals -8. And so that's that. Okay. And so now you guys can go try these 3 problems out, find the focus and directrix and P in those following problems, and let me know if you have any questions, and you guys take care.